So here's the generator test set with the generator running in my garage. Fuel from the tank goes through the fuel flow meter. There's the generator controller. You can see we're putting 4.5 kilowatts. The heat is dissipated by 1, 2, 3, 4 electric heaters. That's the motor that's not working today, not being used today. This is the BetaGen generator, and this flexible hose coupling down through some junctions to a hospital silencer and an absorption silencer, and then a representation of the pipe leaving the boat. This part in between, I just showing this bit, is a quarter wave tube resonator to attenuate the 70 Hz second harmonic. And you can hear that it's making relatively little noise. The noise you can hear is from the casing of the hospital silencer. If I put this right next to the exhaust, there's no noise there at all. Just for reference, there's the microphone I've used. It's a Sub-Zero condenser mic, and the laptop with the spectrum analysis and frequency processing software. So here is the current probe running. The engine's running a light load. You can see the current waveform. Take my word for it, that's 50 Hz. Set it to trigger automatically. It's not quite a perfect sine wave, but it's really very good. And down here at the bottom you can measure parameters here. So we're measuring 82.8 millivolts as an average RMS reading. It's 10 millivolts per amp, so it's currently running at 8.3 amps. And in this way I can get good accurate measurements of the current independent of the generator control system.
For the sound measurements, we use spectrum analysis, where the microphone signal is converted into its frequency response and then plotted on the graph. This is a live presentation of the computer screen. Each time a new measurement is taken, it's averaged with the preceding ones, so the non-repetitive sounds coming from birds and trees and cars going down the road all tend to average out and diminish, leaving the tones generated by the generator as the dominant lines. There are 3 cylinders in the engine. It runs at 1500 RPM, so 38.8 Hz is the firing order of the engine. That is quite a low frequency and not very audible to the ear. The second harmonic of this, at 77 Hz, is not only more easily heard by the ear, but it tends to rise more as the load on the engine increases. The higher frequencies are well attenuated by silencers, but it's the 77 Hz that is the most noticeable sound coming out of the exhaust pipe of the generator. Here are some examples of temperature methods. The engine is running here. You can see a Raspberry Pi computer sitting on the top with 10 temperature probes. To illustrate the probes, there's one on the exhaust duct. Similarly, here's one for the inlet air temperature and the air temperature going into the intake of the engine. Here is an example of temperature test results taken directly off the system. The x-axis is in 10-second intervals, so it lasts for some 3 or 4 hours. The engine starts at the beginning and rises to a steady operating temperature, although some of the results aren't fully stabilized even after the hours running. When the engine is shut down, some of the temperature measurements actually rise. So, for example, above alternator peaks at nearly 90 degrees. This is because the heat of the engine is contained inside an insulated box. Fuel flow measurements were achieved with this calibrated pipe. The valve at the bottom was closed, stopping fuel coming from the fuel tank, and then the generator had to draw its fuel from this pipe. My wife's pharmacy measurements were used to make sure that the volumes were accurate, and then it was just a question of measuring with a stopwatch the time taken for a volume of fuel to be burnt. I hope that's given you some insight into the work we've done to prepare for installing this generator in Perseverance. This control panel, for example, will be inside the cabin because it doesn't need to be next to the generator. We've done a lot of work with the cooling on the engine so that we can put waste heat into the crack. And this silencer arrangement here has an experimental quarter wave tube. I'll be showing you the production version in later blog. But listen to the silent exhaust. This is what Perseverance is all about.